Details of pathological science. Previously we said we are dropping the demarcation problem and now trying to draw a line within science, an epistemically meaningful line between good and junk science. To do that, we said we will look at specific cases. We have already discussed 4 cases of scientists cheating and getting caught. Although these cases were interesting, they didn't tell us what exactly the difference between good science and junk science would be. Then we looked at a case where a scientist who did good science, at least in part, was at least in part falsely accused of cheating. That also yielded some insights, but first and foremost, it indicated that there is no fast and easy way of distinguishing good science from junk. Today we will turn our attention to a curious phenomenon where scientists suffer from what looks like mass hysteria and collective delusions. This phenomenon is sometimes referred to as pathological science, which is a short and cool name, so we are sticking with it. The first example is from early 20th century France, and it originated from a scientist named René Blondlot, who was a physicist at the University of Nantes. Blondlot was a skilled and well-accomplished experimenter. For instance, he was the first scientist to measure the speed of radio waves. In 1903, he announced that he discovered what he called N-rays, a new kind of radiation. The name is supposed to mirror X-rays and pay homage to Blondlot's hometown, Nantes. This alleged discovery created a flurry of activity and publications. Almost 300 articles were published about the N-rays, almost all of which reported observing the effects of the N-rays. Only 26 of these articles were by Blondlot. That means the majority were by other scientists who thought they saw what Blondlot thought he saw. Eventually, the N-rays were shown to be unreal. Curiously, almost all of the reports supporting the existence of the N-rays came from French scientists. To understand why, we need to do a little detour into European history. Let's start with the 30 Years' War. This war was an immensely destructive war. It killed almost 10% of Europe's population at the time. Besides, France and the precursor states to modern Germany were on opposite sides. 30 Years' War contributed to the decline of Catholicism and led to an era of absolute monarchies in Europe. Which brings us to the age of absolutism. This was an era of absolute monarchs and centralization of government power. The most remarkable of these monarchs included Louis XIV of France, Peter the Great of Russia, Maria Theresa of the Habsburg states, and Frederick the Great of Prussia. The age of absolutism gave way to the Age of Enlightenment and the French Revolution. This is when the all too familiar brown objects started to approach the fan. The Age of Enlightenment was sparked by the Europeans landing in the Americas and the Copernican Revolution. Modern philosophers were the chief proponents of the ideology of this age. Today, this ideology is known as the European Enlightenment. They emphasize our shared humanity, the power of human reason, and the value of freedom and equality. These ideas and ideals eventually culminated in the French and American revolutions and paved the way to the contemporary ideologies of liberalism and socialism. A lot happened next. In June 1789, the French Estates Generales, which had been a completely advisory body up to that point, declared itself sovereign over all France. This was quickly followed by major anti-monarchy riots. A military prison, Bastille, was stormed, and political prisoners inside were released by the rebels. Next, Estates Generales abolished feudalism and published the Rights of Man. This document was heavily influenced by the American Declaration of Independence. In 1791, the first French Constitution was ratified. Less than a year later, Louis XVI was arrested and the First Republic was proclaimed. Louis would be later executed by guillotine. Foreseeably, the literal decapitation of the French state led to a bunch of wars and the meteoric rise of a general named Napoleon Bonaparte. Napoleon, who had initially fought against the monarchy and presented himself as the Republic's greatest champion, declared himself the Emperor of the French in 1804. At this point, however, almost the entire Europe was united against France, including the German-speaking states of Prussia and Austria. In 1814 and 1815, Napoleon got defeated and exiled, yes, twice, because he escaped from his first exile and recruited a whole new army in a matter of weeks. Still, he was finally defeated in the Battle of Waterloo, no small thanks to the last-minute arrival of the Germanic Prussian cavalry. Which brings us to the unification and the rise of the modern German state. In 1701, Frederick I proclaimed the Kingdom of Prussia. As I mentioned, Prussia and Austria joined the war against the French Republic, ending with French defeat. In 1815, perhaps the greatest German politician was born, Otto von Bismarck. Thanks to Bismarck's tireless efforts and cunning strategy, the scattered German principalities united under one German state and defeated France in the War of 1870. Noticeably, Germans captured the largely French-speaking region of Alsace-Lorraine. This was followed by another bloody conflict, in part between Germany and France. This time Germany lost. And in 1938, most German-speaking population of Europe united under the rule of this guy, you know very well, creating the largest German state in history. Of course, the guy was no Bismarck, so he threw it all away immediately by starting another world war Germany cannot win. So by the time Blanc claimed to have discovered the N-rays, France and Germany were engaged in a long and bloody rivalry. But the rivalry wasn't just political or military. It was also intellectual, cultural, and scientific. And especially towards the end, France appeared to be losing very badly. From the 18th to 20th century, many great philosophers came from among Germans, such as Kant, Hegel, Fichte, Schopenhauer, Nietzsche, and Marx. German science was equally impressive, if not more. Gauss, Riemann, and Hilbert created mathematics as we know it today. Experimental and theoretical scientists such as Röntgen, Hertz, Planck, Einstein, and Heisenberg revolutionized physics and replaced the Newtonian paradigm with relativity and quanta. What are the philosophical and scientific achievements of the French society during the same time? Not much, other than perfecting delicious but unhealthy food. Of course, I'm exaggerating here. There were some great French thinkers and scientists such as Auguste Comte, Henri Bergson, and Poincaré. But when you do the tally, it looked a lot like the French were lagging behind. Not only politically, but also scientifically. French scientists felt a strong pressure to turn this tide. It is against this historical background Blanc and other French scientists were operating. Blanc and more than a dozen other scientists reported that the N-rays cause various phenomena and can be generated by various other things. Almost 300 articles and a book was published documenting their observations. Looking at this literature, it is impossible to deny that these people sincerely believed that they were studying and documenting a real phenomenon. Curiously, however, as I said, almost all of these 300 articles were written by French scientists. But it all came to a complete stop when an American physicist named R.W. Wood demonstrated the rays to be imaginary. Here's how it went, at least according to Wood's own account. Wood was in England at the time, and he was reading about the N-rays. He tried to replicate the observations of Blanc and others, but he failed. Thinking that he might be missing something crucial, he decided to pay a visit to Blondlot's lab, who graciously allowed Wood to observe the experiments. Wood noticed something, however. The flames and electrical arcs Blondlot supposedly used to detect the presence of the N-rays seemed to flicker at random to him, and Blondlot interpreted this random flickering as the effect of the N-rays. So Wood decided to play a prank and take the matters into his own hands. He secretly removed a prism which Blondlot said was essential for focusing the N-rays, and he put it in his pocket. The room was very dark, and Blondlot didn't notice that the prism was missing. He still proceeded with the experiment and reported seeing the effects of the N-rays dozens of times. Then the lights were turned on, and Wood revealed his prank, and Blondlot was completely flustered. When Wood's account of the encounter got out, the stream of publications professing the reality of the N-rays stopped suddenly and completely. Crucially, no one was accused of misconduct. Blondlot himself continued to work as a scientist, but then chose to retire early. Till his death, he continued to believe that the N-rays were real. Another example of pathological science can be found in the cold fusion fiasco of the late 1900s, which is a period I'm old enough to remember. To understand it, however, we need to understand the underlying science, the science of fusion. Fusion is a type of nuclear reaction where two or more atoms fuse together to produce a new atom. Crucially, it is different from fission, which is an atom splitting into smaller atoms. Fusion of lighter elements like hydrogen tends to generate an incredibly high amount of energy. This has made fusion a popular target for researchers. There are two types of fusion, hot and cold. Hot fusion can happen in two ways. First, it can happen naturally in stars, like our Sun. The incredibly high pressures and temperatures reached inside stellar cores push hydrogen atoms together so strongly that they start to fuse into helium atoms. In the 20th century, scientists also figured out how to create this process artificially. Very simply, they take a fission bomb and put it in a vat of hydrogen. Then they detonate the fission bomb, which very briefly creates the pressure and the temperature you would find only inside a star, which forces the hydrogen in the vat to undergo fusion. This, of course, causes more energy, creates more energy, and creates an even bigger explosion than the fission bomb would. To understand why fusion happens only in stars and nuclear explosions, we need to think about the physics underneath. For atoms to fuse, their nuclei should merge. But nuclei are positively charged, and as you might remember, same charges repel each other. This repulsive force is a function of the charges' distance from each other. Here's the formula actually. As you can see, the force is inversely proportional to the square of the distance. For nuclei to merge, the distance should approach zero. What would happen to the force if the distance in the formula approaches zero? In other words, what would happen if you take a number and divide it with something approaching zero? Answer: you would get a force that is approaching infinity. That's why you would need an incredibly high amount of energy to overcome the repulsive force and fuse atoms. There are some advantages to hot fusion. First and foremost, it explodes. So if your goal is to make a bomb and drop it on someone, it's great. It also has disadvantages. First and foremost, it explodes. That means while it might be good for killing commies or capitalists, it's not good for anything else. You can't produce power with it, for example. So if you are trying to charge your fancy Tesla with it instead of incinerating millions of people, hot fusion is useless to you. What's more, these bombs aren't clean because they require a fission bomb as a detonator, which spreads a lot of radioactive waste. Which brings us to the idea of cold fusion. Cold fusion is a theoretical form of fusion which happens at room temperature. If we could do it, cold fusion would be great. First of all, it doesn't explode, so you can safely harness the energy it generates and turn it into electricity. What's more, it wouldn't produce radioactive waste, unlike fission, which generates considerable amounts of solid waste which stays radioactive for hundreds of years. There's a disadvantage of cold fusion, though. It isn't real. This minor problem, however, didn't stop these two scientists, Martin Fleischmann and Stanley Pons. Fleischmann and Pons were chemists at the University of Utah. Them being chemists is significant because among scientists, chemistry is seen by many as inferior to physics. Like French scientists in early 1900s, Fleischmann and Pons were under pressure to break this stigma. In 1989, they claimed to have discovered how to do cold fusion in a press conference they held. This press conference was followed by a flurry of activity all around the world. Every scientist who could went to their labs and tried to replicate the results Fleischmann and Pons reported. There were even some reports of successful replication. And I even remember one of those reports. I was 7 years old at the time, in 1989. I remember watching on TV a Turkish professor holding a thermos-like thing in his hand and proudly declaring that Turkish scientific community was the 7th team in the world to successfully generate cold fusion. However, these 7 teams must have been very disappointed when it became clear that the overwhelming majority of the scientists around the world couldn't replicate their results. Besides, several scientists directly refuted the reports of success on theoretical and empirical grounds. The story didn't end quickly, though. Convinced that they had stumbled on a remarkable and perhaps profitable truth, Fleischmann and Pons resigned from their professorships at the University of Utah and moved to a private lab in France. For over a decade, they continued to claim that their original results were correct. However, the private investors weren't convinced, and eventually they cut off the funding after spending close to $100 million pursuing the dream of cold fusion. The end of cold fusion came not with a bang, but with a whimper. There are some remarkable differences between cheating and pathological science. Cheating involves fabrication, falsification, and plagiarism. But there is no evidence that Blondlot and his fellow Frenchies or the cold fusion folks committed any fabrication, falsification, or plagiarism. What is more, cheating is conscious and intentional. People like Victor Nino or James Urban make calculated decisions to falsify or fabricate evidence, hoping that they won't get caught. In contrast, the psychological mechanisms that sustain pathological science are unconscious. Cheating is almost always motivated by perceived career pressure. Pathological science, however, is motivated by something more than individual concerns. It's born of cultural and historical factors such as the pressure French scientists felt to prove themselves against Germans, or chemists felt proving themselves against physicists. In a similar vein, the scope of cheating is almost always individual. In fact, the cheater has a very strong incentive to keep everything to oneself. But pathological science is a collective phenomenon. It involves more than one scientist. Finally, when cheaters get caught, their data and results are immediately abandoned, at least when it's a case of fabrication or falsification. Remember Schön, for example, journals retracted dozens of articles by him because he was one of the authors. But pathological science tends to linger. Even when other scientists demonstrate the results to be faulty, the proponents might keep believing. They might even continue doing research to prove themselves right. Can we learn anything useful from pathological science that could perhaps help us differentiate good science and junk science? Sometimes a group of scientists can convince themselves that they are doing good science while they really aren't. Scientists, even as a group, are still human, still fallible. However, there is an argument to be made here to the effect that ultimately science self-corrects. Of course, the word ultimately is crucial here. It might take a long time. Indeed, pathology may last for some time, cause schisms, and persist among scientific minorities indefinitely. And another lesson that reinforces the message from the previous lecture. There is no fast and easy way of distinguishing good science and pathological science. In order to draw the line, you need to understand the scientific concepts and the reasoning underneath. Of course, that raises questions about whether we can draw that line as non-scientists at all. Because after all, the science underneath gets really complicated and impossible to unlock by non-experts such as ourselves. This brings me to the end of this lecture. Send me an email if you have any questions. Thank you for your patience, and I'll catch you next time.